For much of modern history, our collective imagination has painted a bleak and brutal picture of prehistoric life. We picture early humans hunched over campfires, gripping crude spears, locked in a merciless struggle against the elements and each other. It's a narrative built on survival, red in tooth and claw. In this version of prehistory, only the strongest endured. The weak were cast aside. The vulnerable perished. Compassion was a luxury evolution couldn't afford. But what if that picture is not only incomplete, but entirely wrong? What if the most profound discovery in the archaeological record isn't a glittering golden mask or a crumbling stone city, but the quiet presence of love, etched into the very bones of our ancestors? In recent years, a quiet revolution has begun in the world of archaeology and paleoanthropology. Armed with tools far more sophisticated than the chisels and brushes of old, scientists are now decoding the secrets of ancient DNA, peering not only into the physical remains of early humans, but into their genetics, their biology, and, remarkably, their capacity for compassion. And what they're finding is nothing short of extraordinary. Among the tens of thousands of ancient skeletons unearthed in burial sites across Europe and beyond, scientists have begun to uncover the unmistakable genetic fingerprints of people born with Down syndrome. This condition, marked by an extra copy of chromosome 21, is something we often associate with the modern world. We tend to think of it as a diagnosis requiring specialized care, medical infrastructure, and community support. How, then, could individuals with Down syndrome possibly have survived in the harsh world of prehistoric hunter-gatherers? The answer lies not just in the bones, but in the social story they tell. These weren't isolated anomalies. These were children, in some cases, infants, who lived long enough to leave behind meaningful remains. They were buried with care. Some were adorned with jewelry. Others were given space within family homes, treated not as outcasts or burdens, but as precious members of a group that saw value in their lives. This growing body of evidence is forcing researchers to re-examine some of the most fundamental assumptions about our evolutionary past. It's becoming clear that care for the vulnerable, far from being a modern invention, is actually embedded deep within the DNA of our species. In fact, it may be one of the things that made us human in the first place. Let's pause to consider what this means. We often associate the birth of compassion with the rise of civilization, with religion, philosophy, or the advent of writing. These are the pillars of our moral evolution, we assume. But the fossil record is now suggesting that compassion predates all of that. It predates cities. It predates agriculture. It even predates Homo sapiens. Because before us, there were the Neanderthals. Long portrayed as primitive brutes, Neanderthals are slowly being rehabilitated by science. They made tools. They painted cave walls. They may have buried their dead. And now, thanks to the discovery of one small, damaged skull fragment from a child nicknamed Tina, they may also have cared deeply for their sick and disabled. Tina lived more than 100,000 years ago in what is now eastern Spain. She was not like the other children in her group. She suffered from severe physical impairments, including balance issues and partial deafness, likely caused by Down syndrome. In a world without antibiotics or physical therapy, Tina should not have survived long. But she did, for at least 6 years. Why? Because someone, likely many people, helped her. They guided her when she couldn't walk straight. They waited for her when the group moved. They fed her, sheltered her, and made sure she didn't fall behind. In a time when food was scarce and life was hard, a group of Neanderthals chose to extend their resources, their time, and their energy to help a child who may never have been able to repay them. That, right there, is compassion. And Tina is not alone. From Neolithic tombs in Ireland to Bronze Age graves in Greece, more and more cases are being uncovered, each one whispering the same quiet truth. Human beings have always had the capacity to care. Long before hospitals, before religion, before recorded ethics, there was something within us that saw worth in every life, even those who could not contribute in the traditional sense. This is a story that cuts to the core of what it means to be human. Because what separates us from other species is not merely our intellect, or our ability to use tools, or even our language. What separates us, what elevates us, is our willingness to help others when there is no obvious reward, to protect the vulnerable, to love without condition, and now, Thanks to the precision of ancient DNA analysis, we can trace the roots of that love back further than we ever imagined. This project, this deep exploration of prehistoric care, is about more than science. It is about reclaiming a piece of our shared humanity. It is about understanding that compassion is not a cultural invention. It is not a recent trend. It is an ancient legacy that shaped us long before we wrote our first word. So as we embark on this journey, tracing the footsteps of our ancestors, uncovering the buried lives of children who were once seen and loved, we must set aside our modern cynicism. We must be willing to learn from bones, from silence, from the way a necklace was clasped around a tiny neck 3,000 years ago. Because what we are learning is this: our species didn't just survive because we were strong. We survived because we cared. And maybe, just maybe, that's our greatest strength of all. Before we dive deeper into the archaeological findings, it's important to step back and understand the condition at the heart of these discoveries: Down syndrome. To comprehend the full significance of prehistoric individuals with Down syndrome, we need to explore what the condition actually is, what challenges it presents, and why it's so remarkable that these individuals were cared for in times when survival itself was a daily battle. The basics: a genetic variation that happens naturally. Down syndrome, medically known as trisomy 21, is a genetic condition that occurs when a person has 3 copies of chromosome 21 instead of the usual 2. This seemingly small change has significant effects on development, both physical and cognitive. It happens completely naturally during cell division and can occur in any human population regardless of race, geography, or history. It's important to emphasize that Down syndrome is not a disease. It's not contagious, and it's not the result of any wrongdoing or environmental factor. It is simply one of the many variations in the way human DNA can be arranged, a variation that has been with us for thousands, perhaps tens of thousands, of years. And now, thanks to modern genetic tools, scientists can detect the signs of trisomy 21 even in the DNA of people who lived thousands of years ago. But what does this condition actually mean for those who have it? Physical and cognitive characteristics. People with Down syndrome often share certain distinctive physical traits. These can include a flatter facial profile, almond-shaped eyes that slant upward, a single deep crease across the palm, shorter stature, low muscle tone, hypotonia, in infancy. Internally, individuals may experience congenital heart defects in about 40 to 60% of cases, digestive issues or intestinal malformations, vision and hearing problems, increased risk for respiratory infections. Cognitively, most people with Down syndrome have some degree of intellectual disability. This can affect learning, communication, memory, and social behavior. The range is broad. Some individuals live semi-independently as adults, while others require lifelong support. Now, imagine living with those challenges in a prehistoric world, a world without antibiotics, surgery, hearing aids, or even basic sanitation. This is why these ancient discoveries are so powerful. For someone with Down syndrome to survive beyond infancy in those times, they would have required constant, active care from others. Support needs across a lifetime. In the modern world, people with Down syndrome often receive support from a wide range of services: physical therapy, speech-language pathologists, special education, community integration programs, and medical professionals. In infancy, babies with Down syndrome often struggle with feeding, muscle strength, and coordination. Many require assistance just to breathe, nurse, or sit up. In childhood, cognitive delays become more evident. Tasks like walking, speaking, and playing take longer to develop. Even in the best-equipped modern societies, this often places a large burden on caregivers, usually the parents and extended family. And yet, the emotional rewards of raising a child with Down syndrome are well documented. Many families speak of the joy, affection, and resilience these children bring. But the reality remains: it takes time, patience, and collective support. Now imagine offering that same level of care, not in a 21st century hospital, but on a windswept plain 5,000 years ago, or in a nomadic Neanderthal camp, where every day is a new journey in search of food and shelter. In that context, the survival of a child with Down syndrome is not just unlikely, it is almost miraculous. Unless, of course, that child wasn't a burden to the group, but a part of it. A person worth protecting. A life worth loving. Why Down syndrome is traceable in ancient DNA. Here's where modern science enters the story in an unexpected way. For decades, archaeologists relied solely on skeletal remains to understand ancient diseases or disabilities. But bones don't always tell the full story. Many conditions, especially chromosomal ones like Down syndrome, don't leave clear or unique marks on the skeleton. That all changed with the emergence of ancient DNA, ADN, analysis. Scientists today can extract and sequence DNA from ancient remains, even those thousands of years old. The process is delicate and requires cleanroom environments to avoid contamination. But once the genome is mapped, researchers can identify an extra copy of chromosome 21, the hallmark of trisomy 21. This allows researchers to confirm, with stunning accuracy, that individuals buried in ancient tombs or homes did, in fact, have Down syndrome. This isn't guesswork. It's not a hypothesis. It's hard genetic evidence that these children lived, and that their communities likely knew they were different and cared for them anyway. The uniqueness of care in prehistoric times. Today, caring for a person with Down syndrome might involve medications, therapy sessions, mobility aids, and educational accommodations. In prehistory, none of that existed. So what did caregiving look like? Feeding. A baby or child with low muscle tone and swallowing issues would need to be fed slowly and carefully, especially if teeth development or jaw strength was delayed. Mobility. Children with Down syndrome often learn to walk much later than other kids. In prehistoric societies, this could mean carrying the child constantly during migrations. Communication. If verbal speech was delayed or limited, caregivers had to rely on patience, observation, and emotional bonding to understand the child's needs. Safety. Hearing impairment and poor balance, as in the case of Tina the Neanderthal, meant increased vulnerability to predators, accidents, or being lost. Someone had to stay close, always. All of this required not just parental attention, but community cooperation. In a society where survival depended on every able-bodied person contributing, choosing to care for someone who couldn't contribute and might never be able to, is one of the strongest indicators of empathy we have in the archaeological record. Reframing disability in prehistory. In the modern world, disabilities are often framed through lenses of productivity, independence, or burden. But perhaps our prehistoric ancestors saw things differently. Perhaps they recognized value in interdependence. Perhaps they understood that a child who needed care could also provide something immeasurable, a deepened sense of community, of shared purpose, of love. After all, we are a species shaped not just by tools and fire, but by relationships. Why this discovery matters today? As we uncover more and more evidence of ancient individuals with Down syndrome, we are not just learning about biology. We are learning about the social heart of humanity. Each burial, each strand of ancient DNA, each necklace placed on a fragile neck, tells a story of inclusion. And in a world that still struggles with how we treat the vulnerable, the elderly, the disabled, these stories from the deep past serve as both a mirror and a challenge. They force us to ask, if prehistoric communities, with none of the resources we have, made space for people with profound developmental differences, what excuse do we have